May 2nd, 1952, 14:30 Greenwich Mean Time. A de Havilland Comet 1 sits at London Heathrow Airport. The aircraft registration GALYP. British Overseas Airways Corporation Flight 781 to Johannesburg. Captain R.E. Alabaster walks around the sleek fuselage. 93 feet from nose to tail, swept wings. 4 de Havilland Ghost turbojet engines buried in the wing roots. No propellers, no radial engines. This is the jet age made real. First Officer G.F. Power examines the main landing gear. Flight Engineer F. McDonald checks the 4 Ghost engines, each producing 5,000 pounds of thrust. The Comet represents aviation's future. Fast, smooth, revolutionary. The revolutionary aircraft. De Havilland began designing the Comet in 1946. Britain wanted advanced airliners for post-war routes. De Havilland chose jet propulsion when competitors selected piston engines. The risk was enormous. No jet airliner had ever flown commercially. Jet engines consumed fuel at alarming rates. Operating economics were uncertain. But jets offered compelling advantages. Speed, 490 miles per hour. Altitude, 35,000 feet. Smooth flight above weather. The Comet first flew in July 1949. BOAC ordered the type. The aircraft entered service in May 1951, the world's first jet airliner carrying paying passengers. Cockpit and systems. Inside the cockpit, 3 crew positions: pilot, co-pilot, flight engineer. The instrument panel displays conventional analog gauges, airspeed, altimeters, artificial horizons, jet pipe temperature gauges, critical for turbojet monitoring. 4 throttle levers control the Ghost engines. No propeller controls. No mixture levers. Just throttles adjusting fuel flow. Navigation uses radio compasses and VOR receivers. The autopilot maintains heading and altitude, but requires constant monitoring. Passenger experience. The Comet 1 accommodates 36 passengers. The cabin is pressurized, maintaining 8,000-foot cabin altitude while cruising at 35,000 feet. This 8.25 psi pressure differential represents the highest in commercial aviation at the time. The circular fuselage distributes pressure loads efficiently. The cabin features square windows, large windows, generous dimensions. Passengers appreciate the view during high-altitude cruise. Engine location in the wing roots creates a quiet cabin. No propeller noise, no vibration, just smooth turbine operation. Takeoff and climb. McDonald starts the Ghost turbojets using electric starters. Engine 1, Engine 2, Engine 3, Engine 4. The sound is distinctive, high-pitched whine building to steady roar, different from any piston engine. Alabaster taxis to the runway. Tower clears Flight 781 for takeoff. 4 throttles forward. The Ghost engines respond instantly. The Comet accelerates rapidly. 90 knots, 120 knots. Rotate. The nose lifts. The swept wing generates lift. The aircraft climbs at 2,000 feet per minute, exceptional for 1952. Gear retraction. Clean configuration. The Comet continues climbing toward cruise altitude. High-altitude operations. At 35,000 feet, Alabaster levels the aircraft. Above weather, above turbulence, smooth air. Cruise speed, Mach 0.74, approximately 490 miles per hour. Nearly 100 miles per hour faster than piston airliners. The flight to Rome takes 2 hours, 40 minutes. Piston transports require over 4 hours. Passengers experience unprecedented comfort, quiet, smooth, fast. Early success. By May 1952, BOAC has operated Comets for nearly a year. Passengers love the speed and smoothness. The aircraft makes piston transports feel obsolete. Operating costs exceed projections. Fuel consumption is high. Engine maintenance is frequent. But airlines accept these as inevitable with new technology. BOAC operates Comets on prestige routes: London to Johannesburg, London to Singapore. The aircraft demonstrates British technological leadership. The first accidents. October 26, 1952. BOAC Comet Galsy crashes near Rome during departure. 35 people die. Investigation determines probable pilot error. March 3, 1953. Canadian Pacific Comet crashes at Karachi during takeoff. 11 die. Investigation identifies wing stall during improper technique. These accidents appear operational, crew error, unfamiliarity with jet performance, not design problems. De Havilland and BOAC continue operations. The fleet expands. The jet age seems unstoppable. January 10, 1954. BOAC Comet Gal-P, the same aircraft from our opening, departs Rome for London, Flight 781, Captain Alan Gibson, First Officer William Burry, Flight Engineer Frank Reynolds. 29 passengers aboard. The crew reports passing 26,000 feet, climbing normally. Then silence. The aircraft disintegrates in mid-air near Elba. All 35 people perish. No distress call. No warning. Sudden catastrophic structural failure. The investigation. Britain grounds the Comet fleet temporarily. Investigators recover wreckage from the Mediterranean. The search is difficult, deep water, scattered debris. Engineers find no evidence of fire, explosion, or sabotage. The structure failed. The cause remains unclear. De Havilland implements modifications: reinforced structure around windows and doors, improved inspections. The Air Registration Board lifts the grounding after 8 weeks. BOAC resumes Comet operations in March 1954. April 8, 1954. BOAC Comet G-Alwi departs Rome for Cairo, Flight 201. Captain Wilhelm Mostert, 7 passengers. Near Naples, the Comet disintegrates. Again. 21 people die. This time, the grounding is permanent. Every Comet certificate withdrawn. No commercial flights until the cause is found. The water tank test. The Royal Navy recovers wreckage from both accidents. Divers work in dangerous conditions, retrieving fragments. The Royal Aircraft Establishment begins unprecedented testing. They place Comet GALUIU in a water tank. They pressurize and depressurize the fuselage repeatedly, simulating flight cycles. After 3,057 simulated flights, the test aircraft fails. The fuselage tears open. The failure originates at a forward cabin window corner, specifically at the ADF antenna cutout. The discovery metal. Fatigue. Microscopic cracks propagate from stress concentrations at window corners. Each pressurization cycle extends the cracks. Eventually, critical length is reached. The pressurized fuselage tears apart explosively. The square windows create stress concentrations at their corners. The high-pressure differential stresses the structure with every flight. The redux bonding technique masks crack propagation. De Havilland's engineers understood static stress. They underestimated cyclic stress effects. The testing regime did not replicate actual operating conditions sufficiently. The lessons. The Comet disasters kill 110 people. They destroy Britain's lead in jet transport. They devastate de Havilland financially. Boeing and Douglas learn from Britain's expensive lessons. The 707 and DC-8 feature oval windows, conservative pressure differentials, extensive fatigue testing. The 707 enters service in 1958, dominating the market. The Comet 4, redesigned with oval windows and strengthened structure, also enters service in 1958. But Boeing controls the market. The legacy. The Comet accidents advanced aviation safety profoundly. New understanding of metal fatigue, improved testing procedures, changed structural certification requirements. Modern aircraft undergo extensive fatigue testing. Full-scale test articles cycle through entire service lives before certification. Pressure vessels use rounded corners. Stress concentrations are minimized. The accidents demonstrated the importance of systematic investigation, wreckage recovery, water tank testing, methodical analysis. These methodologies remain standard today. The Comet proved jet transport viable. Passengers preferred jet travel. Airlines could operate jets profitably if technology matured. But the Comet also proved that rushing new technology carries risks, that testing must be comprehensive, that unknown factors can kill. The Comet 4. The redesigned Comet 4 proved reliable. BOAC operated the type from 1958 to 1965 without major incidents. The structural problems were solved, but the damage was done. Total Comet production, 114 aircraft. Compare this to 1,010 Boeing 707s and 556 Douglas DC-8s. The Comet's early promise never materialized commercially. The accidents cost Britain its jet transport leadership. American manufacturers dominated for decades. Evening over England. No Comets fly passenger service today. The last retired in 1980. Military variants flew until 1997. Only museum examples remain. But their influence persists. Every modern jet airliner owes something to the Comet. Pressurized cabin at altitude, potted engines, swept wings, the vision of fast, smooth jet travel. The Comet proved what was possible. It showed what aviation could become. It paid in tragedy for lessons that made flying safer. The first jet airliner. Beautiful, revolutionary, flawed. The aircraft that changed everything while destroying itself.